Now remember, if we add something to just x, that's just one x. So if I have one x and I add 4 more x's, how many x's do I have?
4x. 5x.
5 x's. Okay, because I already had an x and then I added 4 x's. So we end up with 5 x's are equal to negative 15. And then we divide by 5, and we get x equals a negative 1. Okay? So we solved our system of equations, right? Right?
Yeah.
Sure?
Yes.
I don't know.
No, yes.
You're thinking like it's not yet.
We have x and then lots of there.
So that's the value for y.
Yeah.
So if I was going to put in a coordinate point on my graph, and I said graph negative 3 comma negative 2x,
What?
you have to find
That's
y.
enough.
First period, we put this little note up here, and I've left it up all day. Don't forget to find x and y. Okay? A solution is going to be a coordinate point. The coordinate point has to have an x and a y. If we just solve for x, we're not doing enough. So we're going to take this equation, y equals negative 2x. But now what additional information do we have? That x equals negative 3. So that's what we're going to do here. We're going to plug that value back in here. X equals negative 3. Now x is being multiplied by negative 2, so we'll have to multiply negative 3 by negative 2. And we get y is equal to negative 2 times negative 3. What's negative 2 times negative 3? Positive 6, because a negative times a negative is positive. So y equals 6. So our solution, and the way we are going to always write our solutions, is negative 3, 6. Okay, Mrs. Farring and I don't want to be hunting around your paper going, I don't know where they put x, I don't know where they put y. You're going to write your solution as a coordinate point. Okay, so the x is negative 3 and the y is 6. And now if I graphed it, I know that my 2 lines, so here's negative 3, here's 6. My 2 lines could be anywhere. I mean, they can't be. They're here. But like, one of them's going to go like this, and one of them's going to go like this. Okay, they're going to intersect at that point. Okay, so remember the solution that we're talking about is always the point where the lines are going to intersect. Only point where x and y are going to be the same for both lines, for both equations. Okay, we are going to dive into some practice. We are still planning on doing evidence tomorrow, although it's just going to be one problem. So we're going to practice today. The more you get done today, the better things will be tomorrow. You can work with your table as long as you are working with your table. All right, there's one correction. There's one correction we need to make on this. If you look at the first problem, it says the graph shows the line for one equation in a system of equations. Draw the graph of the other equation so that the system of equations has a solution of, and it says negative 2, 3. Cross that out and write in a new point, just 2, 3. Not negative 2, 3, but 2, 3. Okay, what that question is really asking you is it's saying like, there's one line there, you know a solution or a system of equations is going to have 2 lines. And if the solution is 2, 3, then And you have to figure out, well, okay, what would the other line look like? Then you've got some systems to solve algebraically. So the first one is on the front under that graphing problem. Pretty straightforward. It's like some of those ones we did in the warm-up. The second one on the back is very similar to this. So I'm going to leave this up here for about 2 more minutes. If you did not get this example down, you're going to want to write it down now. You don't have to do the Hanger diagrams, but this side you're going to want to write down. Okay, so if you didn't write that down,